Welcome astronauts, space seekers, and AWS enthusiasts.
We're here to guide you through security in the AWS cloud, basic principles of cloud security, AWS services for securing user access, and many more relevant security features in this course.
But before we get started, let's talk about your mission. As you know, bee populations are declining around the world, so we task you, eager explorer, to build a bee colony on Mars, codenamed Bee Mars if you choose to this mission.
We'll therefore be showing you how you can secure your AWS resources in this bee-themed endeavor throughout the course. So look out for more puns as we take you on this journey of not winging security.
Each week, we'll have a theme to it, with this first week being the introduction. Week 2 is securing your infrastructure. Week 3 is data protection. And we ended with week 4, securing your application.
Don't fret with the amount of content, as we've packaged them into little videos, reading content, demos, and even fun little quizzes. However, there is no spelling bee.
So get comfortable, log into your account, check out the AWS console, and prepare for blast off your space cadets. Happy building!
Hello, Dumela, Saubona, hello, Molo, and how's it? I'm Rudy, and I'm a solutions architect with Amazon Web Services, and I work across segments like robotics, fulfillment, and last mile. I'm originally from sunny Cape Town, South Africa, and I'm a big fan of education, and have authored 11 exams for several companies, including AWS. In fact, I think my yearning to teach comes from my grandfather, who was a teacher himself, and my mother, who decided to send me for speech and drama lessons. Thanks, Mom. Actually, my mom is enrolled in this course. Hopefully everyone is as amped for this course as I am, and don't worry, it won't be too hectic, brew. Salagashle, shap shap.
Hi there, I'm Hong, and I'm a solution architect at AWS. I've been here almost 4 years. I was born in Vietnam and moved to America 10 years ago. I went to University of Utah and studied marketing and information systems. I have to build this course because I would love to see more women learning about AWS Cloud. Hope you will learn some useful knowledge and have fun in this class. Mong là các bạn sẽ thích lớp học này.
Welcome to week 1. This week is all about the basics. After a quick review of some goals for the class, we'll dive into fundamentals around defining cloud security in AWS with the shared responsibility security model. And we'll talk some about compliance in AWS. After that, it's all about account management. Creating accounts, managing multiple accounts, and securing account and service API calls will all be covered. As there are no labs or exercises in this class, make sure you're reading through the class notes and suggested readings, and really think about scenarios to implement what is covered. Throughout the class, we will walk through several demos where we encourage you to follow along. And I hope you have some fun. I know Rudy and Hong had a lot of fun making this for you.
So what is cloud security? I mean, what is the cloud apart from a magical place where rain gathers? Well, it's the notion of taking IT services, packaging them up into building blocks, and providing them to you and your business on a pay-as-you-go model. An example would be S3, or Simple Storage Service, where you can store objects. AWS itself provides these services upon creation of your AWS account. But as with any service-based model, we want to give you the mechanisms to further secure your account and infrastructure. This means we readily provide services to secure your accounts, like IAM or Identity and Access Management, and Amazon Cognito, which allows you to provision end-user access to your applications. This all rolls up into the notion of a shared responsibility model. This translates to AWS being responsible for security of the cloud. S3 being the example we mentioned, but all of them, like AWS IoT Core, Amazon SageMaker, Amazon RDS, and so forth. We are also responsible for securing the infrastructure of our regions, availability zones, and edge locations. and only authorized personnel are allowed into these physical locations. You then, as a customer, build your workloads using these services, and therefore you are responsible for security in the cloud, i.e. whatever you build must be secured by yourself. Think of it kind of like a home alarm system. We provide it to you, but you still need to go and physically turn it off and on, as we don't really come into your house at night. Or do we? No, I'm just kidding. But let's think of it like this. When a bee comes into this world, it has a stinger. It's provided to the bee, but it still has to use it in the right way. Then again, a bee will die once it's used it. Okay, you know what? Let's just skip to the next section, shall we?
Hi, Hong again. As you are helping to build infrastructure for bee marts, there are compliance programs and standards that you will need to follow. For example, your bee citizen will need to go online shopping for their hive. You need to make sure your environment is PCI compliant so that you can store and process critical information of your bee citizens. Another example is when you need to build a highly confidential system for the queen bees and her government to store secrets, such as hidden hive locations. Thus, you need an environment that is compliant with FedRAMP. No matter how you deploy your IT infrastructure on your own servers or on AWS Cloud, you as an application owner need to maintain adequate governance over the entire IT-controlled environment. There are a few practices you need to follow. First, understand compliance objectives and requirements. Then, you need to establish controlled environment that meet those objectives and requirements. Also, you need to understand validation required based on your organization's risk tolerance. And you need verification of the operating effectiveness of your controlled environment. Now, when you build and operate your IT environment on AWS, it is a shared responsibility model between you and AWS. AWS part in this shared responsibility include providing its service on a highly secure and controlled platform, and providing a wide array of security features that you can use. Your responsibility includes configuring your IT environment in a secured and controlled manner for your purpose. AWS does communicate its security and control information to customers. You can find more details about this in this week's readings. You can also check if a specific AWS service is compliant with specific programs by visiting AWS Service in Scope portal. Again, you can find this link in the resources section. Thanks for watching. See you soon.
As you start your AWS journey, the first thing you are going to need is an AWS account. This allows you access to the console, and by provisioning other users, you'll open up other channels of interaction, like the command line interface, or CLI, programmatic access, API calls, or even be able to use our software development kits, or SDKs, like the one for Java, to interact with your AWS account. When you first create the account, you'll notice that you're using the super user or root user. This means that you can do anything and everything in your account, even deleting resources that you didn't mean to. For that fact, the first best practice is to create individual user accounts for each user and provide them with relevant access. For example, if they need admin access, then provision it. But if they only need read access to, say, a DynamoDB table, then make sure you only provision that. It's called the principle of least privilege access, and likewise means to provision the minimum needed access policies so that users can only perform the work they need to. You can create more users via the IAM console by choosing a username, password, whether you want to access it via the console or programmatically, and then you add policies that stipulate the actual resources they have access to. For the purposes of creating an admin user, you attach the administrator access policy, which is a JSON document that describes it. And you can see an example of what this looks like right now on screen. You can see that there are three main areas of interest. Effect, which can be an allow or deny. In this case, it's an allow. Action, which is what API am I going to allow or deny? And in this case, it's all APIs. Resource, which is where I can execute this against. In this case, it's all AWS resources. We're using the star or asterisk because not only are you a star, but so am I. But you know what? Just usernames and passwords are so last year. We want to add an additional layer of protection for privileged users as another best practice. It's called MFA and stands for multi-factor authentication, and it adds another verification check when you try to log in. This can and should be enabled for your root account, along with each account you're trying to protect. Essentially, you'll be prompted for a code once you've entered your username and password, with the code coming from an application like Google Authenticator, a security key like a YubiKey, or even an actual token device such as a Gemalto token. Other best practices include using strong passwords versus something like, say, password 123, using roles and groups to assign permissions, and even monitoring them using CloudWatch and CloudTrail, or maybe some other AWS services. In fact, that's the assigned reading we recommend, and it'll be listed in your resources section for the week. But with that being said, let's get back to all the fun and games, and how about we show you a demo? Hello Space Explorers, and welcome to the demo for multi-factor authentication, or MFA. In this demo, we'll cover creating a user and then assigning an MFA mechanism to this user. The first thing we're going to do is log into our AWS account with an admin user. Remember, you don't want to use your root account as those should be restricted so as to prevent accidental deletions and other funny business. So if we go in here, you can see that I'm logged in already, and I'm going to go to the IAM console, or Identity and Access Management console. We're going to click on the Users section here on the left navigation bar, and then we're going to click Add User. We're going to give it a fancy name. In this case, we're going to call this user Buzz. We're going to select AWS Management Console access by clicking on this doohickey, kind of also known as a checkbox. So once we select it, you'll see that it gives us the option to choose password generation, and we're going to let it auto-generate a password for us. And in this example, we won't ask the user to reset their password. So unselect this last checkbox. We're going to click the Next Permissions button. And because we want to create another admin user, we'll click the Attach Existing Policies Directly section. You can actually search here for admin, and you can see that it auto-completes. Or for those eagle-eye students, you'll notice that particular policy is at the top of our list. So we're going to go ahead and select it, and then click Next Tags. Now we're going to give it some fancy tags. We'll go with the B Mars for our mission. Click Next and Review, and now we're going to make sure that everything is A-OK. So, yep, kind of looks good. So let's click on the Create User button. And success! We've created a user. Just make sure that you copy these kind of details that are on this page. This is the sign-in URL that you want, and I'm going to copy that here. And the password, which is pretty important if we're going to log in with our user, aptly called Buzz. So now let's click Close. You can see that our user is there in our user dashboard, and we're going to actually click through on the name itself. We're going to navigate now to Security Credentials. So that's a tab that we click, and under the Assigned MFA Device section, we're going to click Manage. Now, this is where you actually assign your MFA token. In my case, we're going to use a virtual authenticator. I've downloaded Google Authenticator to my phone, and I'm going to click Continue here. Now, I'm going to show the QR code, and using my phone, I'm going to scan that barcode. So let's try that out. Scan barcode. Oh, cool. Already came up. And now we're going to enter in 2 consecutive MFA codes. So let me enter in the first one here. And we'll wait for it to tick over to the next one. Oh, there we go. Now we click Assign MFA. Cool, success again. Now we're going to close that, and we're going to try to log in with that user. So let me just log out from my AWS console. I will pull up that URL that was in the Create User screen. Oh, you'll see it's asking me for my username. I know that already. It is Buzz. I'll put in my password, click sign in. Oh, and I'm prompted for my MFA code. So let me check it out on my phone. Click submit, and voila, we're in to the matrix or the AWS account, depending on how you look at it. But anyway, thanks for watching along, and see you soon, Space Cadet. That's it for this section. Hopefully you enjoyed the buzz around securing AWS accounts. Be seeing you soon.
Hello everyone, Hans here. So now we know building BMARS is the right thing to do. We need to hire more people to help out with our missions. We grow in number of teams, organizations, and AWS accounts. Let's say we have 2 AWS accounts, one for storing our data in S3 called Data Account, and one for developer to build applications called Dev Account. You can delegate access across AWS accounts using IAM roles. Let's take a look at how to do it. Hey folks, let's say you have multiple IT engineers that are tasked to manage AWS account and resources. As an IT manager, you will need to grant AWS admin access for your engineers. This tutorial will show you how to create an IAM group for admin users and assign that IAM user to the group. Let's get started. From the AWS Management Console, you can search for IAM service in the search box. Click on IAM, and you will be prompted to IAM console. Let's create an IAM group. On the left side, click on Groups, Create New Group. I will name it as Admin Group. Click on Next Step. Now is the time that we choose an IAM policy to associate to our new group. In this case, because we're creating an IAM group for admin user, I will search for Administrator Access IAM policy. Click on the policy. Next step, we will review the name of the group and the policy. Then we will create the group. Now, this is the new group that you created, admin group. And if you click on it, you will see the name, the ARN of the group. And also, you can see the administrator access policy attached to the group. So now's the fun part. Let's create an IAM user and associate to this group. On the left column, click on Users, Add User, and create a name for your admin user. In this case, I would do admin IT and my name on it. You can choose to allow programmatic access, which means access to API, CLI, or AWS SDK. You can also choose to allow management console access, which means the user can log into AWS Management Console. And you can choose to auto-generated password or to create a custom password for your user. You can also ask your user to reset password when the first time they log in. Next, let's associate the permission. So there's 3 options for you to create permission for a user. The first option is to add user to an IAM group. The second one is to copy permission from existing user. And the last option is to attach existing policy directly to that user. Now, in this demo, I'm going to choose adding a user to a group. And when you do that, you see the list of groups available. Then I'll click on admin group, which is the new group that we created earlier. Next, we're going to do tagging for this IAM user. So tagging is one of the best practices to help you managing resource in AWS account. In this case, I'm going to use the key for tag is department, and the value would be IT because this IAM resource belongs to IT department. When we reviewed, we can see that the username, we can see what type of access the user allowed, and we can also see what group the user belonged to. Now let's create the user. So after you created the user successfully, the console will show you the username, the access key ID, the secret access key, and the password. So you have to download the resource because it will not be available later on the console. You can choose to download by clicking on the download.csv button, or you can choose to send an email with log instruction. So if we go to our IAM group, we will see that right now on our admin group, there's a newly created user, admin IT Hong. Awesome. So now we're done with the demo. You can follow these tutorials for step-by-step instructions in the resources sessions for the week. But now we need to create and manage more and more AWS accounts. It comes with a new problem. How do we scale and automate AWS account creations? How do we make sure that each team or organization has the appropriate permissions to use the right AWS services and resources? We certainly don't want developer Bs to have permission to see the billing and control budgeting. We also want to make sure our sheriff Bs have access to audit AWS activities to detect and isolate if AWS resource and accounts are compromised. Adding to that, we want all the bills in multiple AWS accounts to be rolled up to one central AWS account so that the Queen Bee can pay for all of AWS cost. Here come AWS organizations. This AWS service can help you centrally govern your environment as we grow and scale. Using AWS organizations, you can automate account creation and management, create group of accounts to reflect business need, govern access to AWS services resource in regions by policy, set up single payment method for all AWS accounts with consolidate billing. You can share resources across accounts. AWS organization make it easy for you to share critical central resources across your accounts. For example, you can share your central AWS directory service running on Managed Active Directory with all accounts in your organization for application to access your central identity store. Additionally, you can ensure application resources across your account are created on your AWS Virtual Private Cloud subnet by centrally defining them once and sharing them across your organization using AWS Resource Access Manager. You can find a list of supported services in the resource section of the course. So how does AWS organization work? First, you will choose an AWS account as the master account. Now, you create an organization in this master account. Note that when you use organization to create a new account, an IAM roles will be created so that master account can switch role to access your member account. Then you can either create organization unit called OU or accounts called member accounts under organization. Then you can create service control policy to OU or to the member account. There is a few best practices to note as you're creating a new organization. The first one is plan ahead for the structure of your organization. The second best practice is, for the master account, we recommend that you keep the master account free of any operational AWS resource. In addition to making it easier for you to make high-quality control decisions, this practice will make it easier for you to understand the charge on your AWS bill. The next best practice is to use CloudTrail. Using AWS CloudTrail in the master account to centrally track all AWS usage in the member accounts. Next thing is to apply least privilege practice. When setting up policy for your OUs, assign as few privileges as possible. And for organizational unit, assign policy to organizational units rather than to accounts. This will allow you to maintain a better mapping between your organizational structure and the level of AWS access needed. Well, you need to perform testing, right? You test new and modified policies on a single account before scaling up to organization unit. Automations. Use the API and AWS CloudFormation template to ensure that every newly created account is configured to your liking. The template can create IAM user, roles, and policy. It can also set up logging, create and configure VPC, and so forth. So that's it for managing multi-account and provisioning cross-account access. See you in an upcoming video. Hello again. Let's talk about how you can authenticate and authorize users to access AWS resources. There are 3 use cases when you need to provide access. The very first use case is when the user accessing AWS accounts and resources. An example of this use case is when you enable single sign-on your AWS account to let a developer log into AWS account using credentials from your corporate identity to create and run AWS Lambda function. Another example is you are building an internal reporting portal hosted on AWS that only allow internal employees of your company to log in and see the reports. Since your companies already have existing corporate identities on an Active Directory, you can federate this Active Directory with Amazon Cognito. The second use case would be allowing resource accessing other resource. To allow your application to access AWS services, you need to be able to validate the identity and permissions of your application resources. For example, your containerized application run on Elastic Kubernetes services need to do an API call to query table in AWS NoSQL database DynamoDB. You will need to securely validate the API call and manage permissions for action that your app is allowed to perform on DynamoDB table using short-term credential called IAM role. Using roles help you follow security best practice for granting least privileged access and enable you to manage fine-grained permission for your AWS services and applications. IAM roles enable you to grant the resources access to data without distributing password or API key or hard-coding credentials in your source code. And the last use case is to allow end users accessing the application. Let's say you're building a great, very fun social media application to help end user create a New Year resolution and have their friends and family celebrate their progress. Your application will need to manage user sign up and sign in, and you also need to enable multi-factor authentication when users sign in. Now that we have discussed 3 use cases, the next videos will dive into 5 available AWS services for identity, directory, and access. See you soon! In the previous video, we talked about 3 use cases for authentication and authorization. Now, let's dive into each of the 5 services related to the use cases. The first one is AWS Organizations. AWS Organizations is a service to help you create and manage multiple AWS accounts. Another helpful feature of AWS Organization is consolidated billing, which help you to roll up billings from multiple AWS accounts to a central master account. The second service is AWS Identity and Access Management. AWS Identity and Access Management, or IAM in short, enable you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users in groups and use permissions to allow and deny their access to AWS resource. AWS IAM allows you to do several things. The first thing is to manage IAM user and their access. The second thing is to manage IAM roles and their permission. And lastly, you can manage federated users and their permissions. In this use case, you can use any identity management solution that supports SAML 2.0 or use one of our federation samples, for example, AWS Console SSO or API Federation. To assign permissions to a user, group, role, or resource, you create an IAM policy by using either the visual editor or just the JSON editor. The visual editor guides you through granting permission by using IAM policy without requiring you to write a policy in JSON. To learn more about policy language, see the AWS IAM policy reference link in the course notes. And a small tip, you can use IAM Policy Simulator to test your newly created policy. The link to access the IAM Policy Simulator can be found in the course notes as well. So now you can apply AWS Managed Policy, a customer managed policy, or an inline policy for an IAM identity, such as user or group. Example can be found in the AWS documentation and the class resources. To quickly summarize, an AWS Managed Policy is a standalone policy that is created and administered by AWS. AWS Managed Policies are designed to provide permission for many common use cases. A customer managed policy is a standalone policy that you create and administer in your AWS account. And finally, an inline policy is a policy that embedded in a principal entity, such as a user, a group, or a role. The different types of policy are for different use cases. In most cases, we recommend that you use managed policy instead of inline policy. The third service that we talk about is AWS Single Sign-On. AWS Single Sign-On, or SSO, is a cloud service that makes it easy to centrally manage SSO access to multiple AWS accounts and business applications. It helps you manage SSO access and user permission across all your AWS accounts in AWS organization. AWS SSO includes a user portal where you can let your end user find and access their assigned AWS account, the cloud application, and custom application in one place. Your user simply sign in to use a user portal with credentials they configure in AWS SSO or using their existing corporate credentials to access all their assigned accounts and applications from one place. And the last service I'm talking about in this video is Amazon Cloud Directory. Amazon Cloud Directory enables you to build flexible cloud-native directory for organizing hierarchies of data along multiple dimensions. With Cloud Directory, you can create directory for a variety of use cases, such as organizational chart, course catalogs, and device registry. While traditional directory solutions, such as LDAP-based directory, limit you to a single hierarchy, Cloud Directory offers you the flexibility to create directories within hierarchies that span multiple dimensions. You can find links to various documentation in the course resource. And that's it for this video. I'll see you soon.
We've talked about authentication and authorization of internal or infrastructure users via IAM, but what about end users? And what if we have an existing identity store that we want to reuse? I mean, is that possible? Well, firstly, a best practice is to logically separate your infrastructure users and end users. This means that you can manage them independently and avoid overlap of process. For example, if you had all your users, irrespective of type, in one identity store, and that store had a disruption, you would not be able to effectively shut off access to specific users to debug without some workarounds. As a way forward with your workloads, and specifically web and mobile apps, AWS provides a service called Amazon Cognito. Now, Amazon Cognito itself provides an identity store called Cognito User Pools. This would store all your users so that registration, authentication, and even password resets are handled by the user pool. Now say a user had logged into your application and wants to upload to an S3 bucket. They require access to that bucket. This is where Cognito identity pools come in and allow authorized access to AWS resources. But what if you have an existing identity store? Well, no worries, you can federate or link an electronic identity across multiple systems. With Cognito, you can do that with the identity pool, which means linking your Cognito user pool with, say, an OpenID Connect provider, or even log in with Facebook or Google. At Amazon, we provide these mechanisms because our customers consistently ask for platform freedom, and thus we do not lock you into proprietary systems. Speaking of freedom of choice and existing identity stores, what if you need to integrate with a Microsoft Active Directory identity store? As a reminder, Microsoft Active Directory can be used to enforce security policies, such as verifying if a logged-in user is an administrator or an end user on Windows domains. And for this particular case, AWS provides a service called AWS Directory Service for Microsoft Active Directory, or the less tongue twister titled AWS Managed Microsoft Active Directory. The two ways you can use it is to federate, and no, not like the Federation of Planets, but to join your existing directory to the AWS one. Now you can remember. This allows you to use EC2 or Elastic Compute Cloud, RDS for SQL, and other services that utilize Active Directory with your identity store and therefore not have to recreate all your users from scratch. You can even use single sign-on or SSO to provide a seamless integration between different services. SSO means that a user would log in once and then be able to access, say, 2 different applications without having to log into each one individually. Lovely, right? I don't know about you, but having to remember one less password is definitely a plus for me. Granted, you can still use Managed AD as a standalone service, and this is usually for customers who do not have an existing identity store. Mind you, if you don't need the full feature set or even deployment footprint needed by Managed AD, don't fret. We've got you covered with Simple AD. It's a standalone managed directory that's available in 2 sizes, small and large. Small for up to 500 users and large for up to 5,000 users. This means that again, you do not have to manage user accounts and build a mechanism around it. Some of the benefits of Simple AD are plug and play with apps that use Active Directory, access to AWS applications like Amazon Workspaces, Amazon Workdocs, or even Amazon Workmail, point-in-time recovery along with daily automated snapshots, and so on. By the name, however, you've probably guessed that it's kinda simplified. Therefore, you do not get certain capabilities with Simple AD, such as AWS SSO or support for Amazon RDS for SQL Server. For the full list of supported and unsupported features, please check out our resources section. One other feature to mention is Active Directory Connector. This is useful if you want to reuse an existing on-premises Microsoft Active Directory without caching any information in the cloud. This means that you can use your existing corporate credentials to log into AWS applications like Amazon Workspaces and even manage AWS resources like S3. Similarly, as with Simple AD, it comes in 2 sizes, small and large, and you can spread out application load against multiple AD connectors. And as always, thanks for joining us in this explanation of identity providers and directory services.
Yay, it's week 2. Now that you've been introduced to some of the basic concepts and our mission, let's start going a little deeper. Focusing on infrastructure security this week, our big topics will be things like network isolation, monitoring, and auditing. As our wonderful Space and B enthusiasts keep taking you through security in AWS, make sure you keep looking at those suggested readings in the notes. Those will take you even further and really help to fill in those gaps.
Hey, what's up? I'm Hong.
And I'm Rudy, and we're going to talk about network isolation.
AWS has placed a limited number of access points to the cloud to allow for more comprehensive monitoring of inbound and outbound communication and network traffic.
These customer access points are called endpoints, and an endpoint is a URL that is an entry point for a web service.
Some service, such as IAM, do not support regions. Therefore, their endpoints do not include a region.
If a service supports regions, those resources in that region are independent. For example, US West 2 is an entry point for all AWS services in that region.
Endpoints allow secure HTTPS access, or we call HTTPS, which allow you to establish a secure communication sessions with your resource running in AWS service.
As we build out our infrastructure on the planet, we want to isolate certain pieces so that we minimize the surface area that can be attacked, whether this is an alien trying to gain access or even asteroids crashing into the surface.
Think about it like a fort. We're building a fort on this barren planet so that we are protecting ourselves and the bees.
But if we go further, we can build hives inside our fort so that we isolate the hives inside the fort itself.
AWS offers the Amazon Virtual Private Cloud, which provides a private network within the AWS cloud. Amazon VPC provides not only isolation from other customers in the private cloud, it also provides layer 3 isolation from the internet as well.
Your Amazon VPC uses IP address spaces allocated by you. These can be used to build a private infrastructure where networks are isolated from the internet.
You can connect your on-premises environment or other VPN infrastructure to Amazon VPC using IPsec tunnel and AWS Server Connect.
And of course, you can allow resources in your VPC to talk to the internet if you choose to do so.
Let's dive into available features of VPC in the next video. Rudy, do the thing.
Welcome to the video on VPCs or Virtual Private Cloud. And before you ask yourself what it is, rewind this video. It's literally in the name. But I don't expect you to actually rewind. I mean, what are we in, the 80s? Next thing you'll be cleaning your VCR and putting on some swanky leg warmers. But I digress. A VPC or Virtual Private Cloud is a way to logically separate your AWS infrastructure from other customers. Think about our bees. We want to create a fort around them, our AWS account, and then go further and isolate them into hives. So if we go into the VPC itself, we want to minimize the risk to our most critical infrastructure. And we can do this with subnets or a logical subdivision of our IPs. For example, we want our fighter bees or EC2 instances to be able to access the internet and be accessed from, so we put them in a public subnet. This is done via NACLs, not Sonica NACLs, but Network Access Control Lists. These lists contain IPs which are allowed or denied access to the subnet. They are also stateless, so if you allow something in, you must explicitly allow it out via a rule. Taking our illustration into consideration, you can see we are allowing inbound access on all IPs via the TCP protocol on port 80. And as I mentioned, these rules are stateless, so we need to explicitly add an outbound rule if we want our traffic to be able to return. Now with our Queen Bee or RDS cluster, we don't need to allow access via the internet as it's handled in the application sitting on our EC2 instance. So we make this a subnet that is private. This means it's not visible to the internet and our queen is in safer hands behind her private quarters. Now say you want to go further and protect a single fighter bee or EC2 instance. You can provision a security group for it. Security groups act as firewalls for associated Amazon EC2 instances, controlling both inbound and outbound traffic at the instance level. This fine-grained access is defined by allow rules and look as follows. In this example, we see that we are allowing SQL traffic to a database server, similar to a NACL. The difference being that security groups are stateful, so return traffic is automatically allowed, regardless of any rules. And that's it for VPC in this video. Next up, you'll learn about private links. You've learned about what a VPC is and how you can isolate certain parts of your infrastructure. But how do you secure them further when sending traffic between VPCs? Take our bees as an example. If we have two hives, or VPCs, or VBCs, we'd have to send the bees outside and through the internet if we want them to travel between the two. This is not ideal because who knows what lurks out there. Never fear, as you can utilize an AWS feature called VPC Endpoints or private links. This allows you to route your bees through a secure endpoint in one VPC and to another. This means they do not leave your AWS infrastructure and do not go through the internet, resulting in a safer path of travel. Translating all of this to AWS speak, we can see that without private link VPCs, we would need to send traffic through the internet in order for VPCs to talk to each other. However, when you configure a private link, you are indeed allowing traffic to flow directly between your VPCs. Fantastic stuff, I must say. I mean, have you ever seen something so beautiful? One more thing to go over is route tables. When you provision a VPC, it comes with an implicit router. Think of your router at home. You connect your PC to it in order to access the internet, but you can connect multiple devices. In order for the receiving traffic to end up to the right device, it is routed accordingly. Devices can communicate to each other, and thus local routes are possible too. If we think about this in VPC terms, this is called a route table, which contains a set of rules or routes that are used to determine where network traffic is directed. A default main route table is set up for a VPC, and you must associate a subnet with an actual route table. It doesn't have to be the main table, and you can create a custom route table to route traffic accordingly. I recommend reading the information about route tables in the notes, especially since I threw in as many routes into that part, and because Hong hates my South African pronunciation of route versus route. I mean, you could route tables, and a tree has routes. You can also root for your favorite sporting team and eat lots of fruit. Okay, the last one doesn't really count, but she's giving me bad looks from behind the camera, so I think I'll close out right there. Thanks for watching, and see you soon.
Hello, it's Hong again. To improve ability to protect your bee fort, bee citizens, and valuable honey deposits, you as a builder will need to improve ability to identify a potential security threat or incident. Detective controls is a term that describes a continued improvement in monitoring of events and processing of logs that allowed for auditing, automated analysis, and alarming. Detective control are an essential part of governance frameworks and can be used to support improvement process of your security operation, a legal or compliant obligation, and for threat identification and response efforts. There's a different type of detective control. For example, conducting an inventory of AWS resources and their detailed attributes promote more effective decision-making, and lifecycle controls to help establish operational baselines. You can also use internal auditing, an examination of controls related to information system, to ensure that practice meet policy and requirements, and that you have set the correct automatic alerting notification based on defined conditions. These controls are important reactive factors that can help your organization identify and understand the scope of anomalous activity. So your mission in the next 2 videos is to understand how to implement detective control by processing logs, events, and monitoring that allow for auditing, automatic analysis, and alarming. That's it for now. This video will self-destruct in 5 seconds. Well, it's not working. Let's just move to the next video then.
You're probably producing lots of honey by this time and want to ensure that everything is operating smoothly in your colony. This means auditing who's doing what is being done, and are there ways to improve security and compliance across the board. Essentially, you're inspecting your infrastructure and service usage to make sure that nobody is winging it in your system. The first AWS service that we will explore is called AWS CloudTrail. It enables you to see who is doing what in your AWS infrastructure. You can track user usage of the console API calls, AWS SDKs, command line tools, and other AWS services themselves so that you know who is interacting with your infrastructure. The best part is that it's enabled by default, and you can view your account activity for the past 90 days right in the CloudTrail console. How cool is that? This allows you to see who is interacting with specific components in your system and can therefore help you trace an errant change, or maybe find out who's been taking data out of your S3 bucket without permission. You can even go further and direct CloudTrail events to Amazon S3, Amazon CloudWatch events logs, and events. This allows you to perform analysis, archive events, and even remediate on an unexpected change. As a best practice, we recommend looking into this service early on in your AWS journey, as you can build in safeguards and auditing so that if you ever need to produce the data, you'll have it ready for auditors. Next up is AWS Config, which is an auditor's dream for configuration management. This fully managed service records your AWS configuration, changes to that configuration, or a history if you want to think about it, and even change notifications so you're notified proactively. Say you've configured all your AWS resources, but since you've got a whole team of busy bees, you might not know who's been configuring what across the team. Fire up config and it will discover these existing AWS resources and generate a full inventory along with all the actual configuration details for you. You can then determine how a resource was configured at any point in time. You can even tie this into the aforementioned AWS CloudTrail so that you gain full visibility into who made the actual change at that point in time and what the change was. For example, say we configured a custom rule to check if an S3 bucket should have non-public access. We can then trigger that rule whenever a change is made, i.e. change triggered, or we can run it in a periodic fashion, like say every 1 or 6 hours. If that rule picks up that public access has been enabled, we can execute a Lambda function to go in and correct access to non-public. The next service we recommend is called Amazon Inspector. This inspector gadget kind of helps you improve security and compliance of your AWS deployed applications by running an automated security assessment. This way, you can avoid a penny for your thoughts and instead use the brain built into Inspector itself to check on deviations of security best practices, exposure of EC2 instances, even vulnerabilities. The service consists of 3 parts: a network configuration reachability piece, an Amazon agent which can be installed on EC2 instances, and a security assessment service that brings them all together. It works by running an assessment based on your specific configuration choices and then outputting a list of findings for potential security issues. The resulting findings are displayed in the Amazon Inspector console, and they are presented with a detailed description of the security issue and a recommendation on how to fix it. Additionally, you can retrieve findings through an API so as to go towards the best practice of automating your remediation processes. I mean, wowza, that's pretty cool. This means you get all the info in a ready-to-consume fashion in both avenues. Kinda way to go, Inspector Gadget. The last service we'll touch on in this video is called Trusted Advisor. This service assists you in provisioning your AWS resources using best practices. It then produces a report under 5 different categories: cost optimization, performance, security, fault tolerance, and even service limits. Once you run Trusted Advisor, you will be presented with a report that you can then drill down into. Each category will produce traffic light-based recommendations. These go in increasing severity, where green means no action recommended, orange for investigation needed, and red for action recommended. Since we're diving into security in this course, I want to highlight some of the best practices that are scanned and reported on in the security section itself. Some of these include S3 bucket permissions, so whether you can actually access a bucket publicly or privately. Security groups, whether your ports are unrestricted, so you can go in and configure rules to close those actual loops. IAM use, so usage of users, roles, policies, and so forth. This is sometimes a mind bender to figure out kind of the correct way to provision your IAM resources, but stay the course and you'll be guided by this report if you are lost. We've also got MFA on root account, so that's whether you're using a multi-factor authentication tool on your root account itself. Exposed access keys. Make sure your access keys are not hard-coded somewhere. And IAM password policies. Rotation of passwords is pretty important, so make sure that you do not let your credentials become stale. It should also be noted that some of these checks are free and some incur a cost. So for a complete list of checks, check out our resources section. And again, thank you for watching and see you soon.
Oh, hi. So glad you decided to accept the mission to implement monitoring as a part of detective controls. Hope your detective instinct is still buzzing. So what on earth is monitoring? Oh, wait, we're not on Earth, we're on Mars, remember? Anyhow, monitoring is to collect, track, and display data and statistics related to your IT infrastructure. In AWS Cloud, there are multiple available services and tools to help you monitor AWS resource and application. So let's start with CloudWatch. Amazon CloudWatch is basically a metrics repository. An AWS service, such as EC2, puts metrics into the repository, and you retrieve statistics based on those metrics. If you put your custom metric into repository, you can retrieve the statistics on these metrics as well. Oh, and the best part is, when a certain metric crosses the threshold that you set up, CloudWatch can generate an alarm. An alarm watches a single metric over a specific time period and performs one or more specific actions based on the value of the metric relative to a threshold over time. The action is a notification sent to an Amazon SNS topic or an auto-scaling policy. For example, you can use CloudTrail to monitor activity related to changing an EC2 security group and trigger Amazon CloudWatch alarm when configuration changes happen. Also, don't forget that you can use CloudWatch logs to monitor, store, and access your log files from multiple sources. Let me share with you some use cases for using CloudWatch logs. The first use case is to collect and store application logs and server operation system logs. Another use case can be to use CloudTrail to capture API activities and send them to CloudWatch logs. Also, you can log Route 53 DNS query into CloudWatch logs. And you can use CloudWatch logs to retain and archive log data in S3. And lastly, you can use CloudWatch Log Insight to interactively search and analyze your log data. That's it for this video. See you soon. You know, as our BMARs are getting more popular, more and more bad aliens out there are secretly looking for a weak spot in our infrastructure. As we're getting smarter in running and securing BMARs, we want to use automation and machine learning to detect and react to suspicious events happen to our environment, which can be caused by bad aliens. And that's why we need to talk about Amazon Guard Duty. Amazon Guard Duty is a threat detection service that continuously monitors for malicious or unauthorized behavior to help you protect your AWS account and resource. This service uses machine learning, anomaly detection, and integrated threat intelligence to identify and prioritize potential threats. Guard Duty analyzes tens of billions of events across multiple AWS data sources, such as AWS CloudTrail, Amazon VPC flow logs, and DNS logs. You can aggregate Guard Duty findings across multiple accounts. You can also integrate Guard Duty with AWS CloudWatch events or your current event management system to alert your security team, aka the Sheriff Bees. Amazon Guard Duty provides 3 severity levels, low, medium, and high, to help you prioritize response to potential threats. A low severity level indicates suspicious or malicious activity that was blocked before it compromised your resource. A medium severity level indicates suspicious activity. For example, a large amount of traffic being returned to a remote host that is behind a hidden network. A high severity level indicates that the resource in question is compromised and it is being actively used for unauthorized purpose. An example of this could be that an EC2 instance has been compromised or a set of IAM user credentials has been stolen. Ooh, bad actor. So, now you can use GuardDuty to detect threats. How about responding to these findings? Amazon GuardDuty offers HTTPS APIs, CLI tools, and Amazon CloudWatch events to support automatic security response to security findings. For example, let's say GuardDuty detects an EC2 security group that accepts traffic from everywhere in the internet. You can automate the response workflow by letting GuardDuty sending the findings to CloudWatch event as an event source to trigger an AWS Lambda function to update the security group. So, are we done yet? Not really. Let's talk about how you can see all the security alerts and compliance status across AWS account in one central place. Entering Security Hub. With Security Hub, you now have a single place that aggregate, organize, and prioritize your security alerts or findings from multiple AWS services, such as Amazon GuardDuty, Amazon Inspector, Amazon Macy, as well as from AWS Partner Solutions. Your findings are visually summarized on integrated dashboard with actionable graphs and tables. You can also continuously monitor your environment using automatic compliance check based on the AWS best practice and industry standard that your organization follows. So that's it for this week, folks. I'll see you again next week.
Hello, Space Explorers. Are you ready to blast off with an AWS Config demo? If you are, good news, we're about to start. But before we dive into the config console, we gotta create an S3 bucket to store our config data. So you can see I've got the S3 console open here, and I'm going to create a bucket. I'll give it a name. So this is Buzz Bucket. If you note, the bucket must be a unique name. So we've got Buzz Bucket here. You can see that it's telling me that I have to be wary of the case too. So let's just change that to all lowercase. Buzz Bucket. We will click next. Oh, the name exists already. See, that's how I'm saying it needs to be unique. So let's do the Buzz Bucket 123. Click next. We're gonna go down here. Everything looks good. We're gonna block public access. And in this case, I wanna say yes. I wanna grant Amazon S3 log delivery to write access for this bucket. So I click next. Again, I'm going to create the bucket now. So you can see we've created our bucket now, and we actually need to go in and create a service role for config to use. So let me click on services. I'll click on IAMs, or identity and access management. And I'm going to create a role now. So if I click on roles, I'm going to create a new one. In this case, we're using an AWS service, so AWS config. Kind of look for it here on our console. There it is. We're going to make it customizable. So we'll click next on the permissions. You can see it adds a default policy here. We want to go to tags, put in our bmars tag. Click next, give that role a name. So let's call it Buzz Role. And we're going to create the role. Now I'm actually going to go back into that role because I want to add additional permissions so that AWS config can read and write to S3. So I've clicked into that role and I'm going to attach another policy. In this case, it's the S3 one. And you can see I'm searching for it under filter policies. I select Amazon S3 full access and click attach policy. And now we've got the correct policy. We can proceed to the AWS config console. So I've actually got that pulled up here, and I'm going to click on get started. You can see here, it's a few fancy options. We've got the create bucket, but in our case, we're going to choose the bucket that we created. And that was called Buzz Bucket 123. We're also going to go down here and choose that existing role that we created. In this case, Buzz Role. We're going to click next. And you know what? Let's add one of these default rules here. Let's do auto scaling ELB health check. We'll click next. confirm everything is A-OK, and click Confirm. Cool, and you can see that we've created our AWS Config configuration. We can also add rules. So in this case, I'm going to click Add Rule, and for argument's sake, I'll pick this one here for access key rotation. So you can see that takes me to the rule itself with default values populated. In this case, we'll keep it at periodic checks, and let's change the frequency to 3 hours. You can also choose your remediation action here, and you can click Save. I'm showing you kind of default values, but when you go in, you're going to set up Lambda triggers and so forth. And you can see that my rule has been created, and right now there are no resources in scope. So it's as simple as that to kind of set up your AWS config configuration. And in our case, maybe the next rule we'll create is to make sure our spaceships are maintaining their orbit around the red planet. So thanks for watching, and hope to see you soon.
Hi y'all, I'm glad you're still buzzing along in week 3. Where last week introduced a lot of services that you can use for your infrastructure security, this week will be more about methodology. Our focus this week is data protection, and we're going to look at this in a number of ways. You'll get information about types of data, encryption in transit, encryption at rest, ways to work with data-centric services more securely, and more. Data is our most valuable resource in the cloud, so make sure you are really diving into ways to implement the things discussed this week. And as always, keep going through those course notes for some great additional information.
Hey there, I'm Rudy, but since I'm in a bee suit, you can call me Buzzy for today. And phew, have I been quite the busy bee the last few days. Our colony is shaping up more and more as we deploy infrastructure to the Martian surface. We are therefore generating lots of data, and we need somewhere to store it. We could just archive it, but that's only if data is not needed immediately. So what are the options of securing our data for the busiest of bees? Well, firstly, we should revisit the notion of least privileged access. What this means is that you should only provide the minimum required permissions for users of your AWS resources. These users could be infrastructure users, end users, busy bees like myself, or even AWS services themselves. For example, if we needed a Lambda function to pull out some info from an S3 bucket, it would need read access to that bucket. Similarly, if the data was stored in an Amazon DynamoDB table, we would provision read access to the relevant table. One of the main reasons we do this is to prevent exposure of critical data to unwanted parties. I mean, we could have our honey stored in DynamoDB, but maybe an alien is trying to access it using compromised credentials. We are also trying to prevent accidental creations, reads, updates, or deletes. This is also known as CRUD functions. Another thing to consider is the access frequency of data. Does it need to be accessed quickly or less? Does it need to be stored for days, months, or years? And even what type of data you're storing. Are you storing objects, rows, time series data, or any of the other types? As a starter guide, if you're looking to store objects, you can use Amazon's Simple Storage Service, or S3. S3 allows you to make data accessible over the internet. And as the most cost-effective storage mechanism offered by AWS, you can even store log files or archive data to S3. Speaking of archiving, if you don't need this data in a hurry, then you can archive it to Amazon Glacier, which lowers your cost even more. Better yet, you can set up lifecycle policies to archive data automatically after a certain period. So if you needed the data to be in S3 for 30 days, then you set up the policy to automatically move it or archive it to Glacier after those 30 days. The next thing you'll probably be looking into is storing data for your applications, user-generated data, and have relationships between those data sets. Thus, you're looking for a relational database, and there are various ones offered under the Amazon RDS or Relational Database Service portfolio. Some options include Postgres, MySQL, and even commercial offerings like Oracle and SQL Server. For those of you who want a more performant and cost-effective database, we recommend Amazon Aurora, which comes in 2 flavors, MySQL and Postgres. The MySQL version is up to 5 times more performant than standard MySQL, and the Postgres version is 3 times more performant than standard Postgres. For a full feature comparison, you can check out our resources section. But you know what? Not all applications require relational databases, and therefore we offer a non-relational or NoSQL alternative called Amazon DynamoDB. This key value database store offers single-digit millisecond access times and can scale up and down automatically. As an added performance gain, you can attach Amazon DynamoDB Accelerator to your DynamoDB tables, which is an in-memory cache which lowers the response time to microseconds. That is lightning fast. Ka-chow! Speaking of speed, pop quiz, hotshot. Welcome back. I hope you got the correct answer. I mean, how could you not get it right? The answer was clearly B. 3 other mentions for databases are our time series optimized database, aptly called Amazon TimeStream, and fully managed ledger database called Amazon Quantum Ledger Database. And last but not least, Amazon Neptune is our graph database service. So instead of leaping between options, you can now go straight for home and use one of these database options in your applications. Apart from databases, you might recall we rolled out some EC2 instances throughout our planetary endeavor. These EC2 instances are generating data and we need a place to store it. The first option we have is Amazon Elastic Block Store, or EBS, which is used for writing block storage. These are automatically replicated within availability zones and offer a non-transient option for EC2 instance storage. With EC2 instances, if you usually stop them, you're going to lose anything that was on the instance store itself. However, if you attach an EBS volume, that data is retained even when shutting down that instance. The second option for storage is Amazon Elastic File System, or EFS. And as the name implies, it's used if you need a file system attached to your EC2 instance. It's fully managed and can automatically grow or shrink depending on whether you add or remove files. For secure data warehousing, we recommend Amazon Redshift, which allows you to store your data in a columnar format. This, along with parallel query execution, means you'll get results up to 10 times faster than other solutions. As an added option, you can even access data stored in S3 via a feature called Redshift Spectrum, thus allowing for even more data to be queried to ensure accurate and up-to-date results. And for those of you wondering if you have to use Redshift for data warehousing, the answer is a most resounding no, you don't. You can use a service called Amazon Athena, which will scan data housed in your Amazon S3 buckets via standard SQL queries. It's a serverless offering, so there's no infrastructure to manage, and the cost is associated with the amount of data you scan, coupled with the query execution duration. But this kind of sounds like we're going into data lake territory here. And you know what? Customers kept telling us they were setting up their own data lakes as a priority, but they weren't sure how to kind of set it up. So we listened and created AWS Lake Formation. And AWS Lake Formation allows you to do that data lake setup in mere days. One of the last few service areas to touch on are our AWS data transfer options. I mean, since we're on Mars, we have no idea what the Wi-Fi is like, and if there's even enough bandwidth to copy terabytes of data to the AWS cloud. This is where AWS Snowball comes in. It's a portable device and can store petabytes of data. Data is copied over to the device with encryption, and it ships out to us at AWS. Once we've copied it to your account, you'll get notified of its availability. And if petabytes aren't enough, we offer an actual truck to move exabyte scale datasets into and out of AWS called AWS Snowmobile. I mean, this thing is huge. But before I digress into the intricacies of trucking solutions, I'll mention the offerings I described have various encryption options to further secure your data, and that you can control those secure keys as well. We'll touch upon those in subsequent videos. If you want to learn more, check out our resources section for a link to a nice matrix of AWS storage options. I mean, we can lead you to the door of these solutions, but only you can open it. Thanks for learning about available secure storage solutions. And remember, there can be only one. Well, actually, there are several, but till next time, Shlalagashle, goodbye, cheers.
Hey, bee lovers and spray explorers! Just as honey is so important to a bee, customer data is very important to your application. Handling customer data without thinking ahead on how to secure it can impact credibility of your organization and your company. As bee citizens are more connected because we bring the internet to Mars, more applications and systems on Mars are producing data, storing data, and exchanging data. In this video, we are focusing on how you can reduce the risk of unauthorized access or exposure of customer data when it's in transit between system and service. The first thing to do is to define requirements for data protection in transit. Based on legal and compliant requirements, you classify data into multiple categories, which is dependent on sensitivity level of the data. Then you apply encryption standards to the right category. For example, historical weather data is considered public data, so you don't have to require encryption in transit when working with this data. However, customer credit card information is highly confidential data, thus you want to make sure it is encrypted in transit. You also need to authenticate network communications. So that includes verifying the identity of communications by using protocol, such as Transport Layer Security, or TLS in short, or using IPsec. Internet Protocol Security, or IPsec, is a protocol for in-transit data protection between hosts. It is a protocol to protect communication at the network layer, which is layer 3 of the OSI model. IPsec can be implemented when you set up Virtual Private Network, or VPNs, to create a secure connection between your VPC and on-premises network. Transport Layer Security, or TLS, is a set of industry-standard cryptographic protocols used for encrypting information at the transport layer, which is layer 4 of the OSI model. TLS is the successor of Secure Sockets Layer, SSL, but SSL and TLS use X509 certificates to authenticate the server. Both SSL and TLS negotiate a symmetric key between the client and the server that is used to encrypt data flowing between two entities. You should use HTTPS instead of HTTP for data transmission. HTTPS uses the SSL TLS protocol to prevent eavesdropping, unauthorized alterations, and unauthorized copying of your data. All AWS services provide API endpoints that allow you to establish secure HTTPS communication sessions. For your web application, you can choose to terminate the encryption at the application layer or at the load balancer layer. You want to make sure you store the X509 certificates securely and rotate them with strict access control. The good news is you can use AWS Certificate Manager, or ACM, to do this. ACM handles the complexity of creating and managing public SSL and TSL certificate for your website and applications. You can use public certificates provided by ACM, called ACM certificates, or certificate that you import into ACM. That's all I have for this video. Be seeing you soon. Buzz, 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 buzz.
So we've got more hives scattered throughout our colony, and we want to make sure they are all safe. This leads us to the concept of when data is not being accessed, is it secure? One way to secure your Hive data is to lock the Hive away and carry a key with you. This AWS concept is called encryption at rest, and there are two services we're going to touch on here. Think about your key. Do you want to manage it, or do you want AWS to manage it? Do you want it to also be created by AWS so that you can let us do the heavy lifting of generating new keys on a fixed schedule? These kinds of questions lead us to Amazon Key Management Service, or KMS, which will allow you to easily manage the encryption keys used to encrypt your data. The primary resource here is called a customer master key, and you use that to encrypt and decrypt up to 4 kilobytes of data. These CMKs can be managed by you, which will give you full control of them. You manage everything from rotation to deletion, IAM policies, and so forth. The other type is AWS managed, and these are created, managed, and used on your behalf by an AWS service that integrates with KMS. Both of these types live in your AWS account, whereas the third type, called AWS owned, lives outside your AWS account. Think of them as part of a collection of CMKs that AWS owns and manages for use in multiple AWS accounts. AWS services can use AWS-owned CMKs to protect your data. But what if your company wants you to manage these keys using dedicated hardware? Well, that's no problem, as the second service we're going to cover is AWS Cloud HSM, or Hardware Security Module, and it accomplishes just that. Cloud HSM is a cloud-based hardware security module that enables you to easily generate and own encryption keys in your AWS account. This helps you meet corporate, contractual, and regulatory compliance requirements for data security by using that dedicated hardware. Let's conclude this video with a short demo on how to create a KMS key. Hey there students, it's Rudy again, and we're here to talk about KMS. Specifically, we're going to give you a little demo. And in this demo, we're going to show you how to create a KMS, or Key Management Service key. And these, if you remember, are used for encrypting and decrypting your AWS data. So let's get started and navigate to the KMS console. You can see that I'm logged into my AWS Management Console, and conveniently under my recently visited services, I've got KMS. I will click there. You can see I don't have any keys right now, so I'm going to click Create Key. I'm going to give it a snazzy name. Let's call it Gatekeeper. And we'll say it is the compatriot of the key master. So we'll click Next. And we'll add some tags. In this case, our mission is called BMARS, so we're going to add that tag or set of tags. And now we're going to define key administration permissions. So these are users that can perform administrative tasks on your key. In this case, we're going to choose Buzz because it's his key. We'll click Next. Next up, we're going to define key usage permissions. That's very similar to the previous screen, but you will now select the users and roles that can use that CMK you are creating to do the actual encryption and decryption. So I'm going to select Buzz again, and I'm going to click Next. You can see we can review and edit our policy inline if needed. Very similar to IAM policies in the case that it's JSON based. So everything looks good, and I'm just going to click Finish right here. Wow, that was quick. I mean, congrats, you just created your first KMS key, and you can now use it in your account. Thanks again for tuning in, and don't touch that dial as we're going to get more fun content dialed up in a jiff. Thanks for watching, and have a good rest while we decrypt the next video. Actually, not just yet, as you have a short quiz to complete, which is key to your success. I mean, so many puns, so little time. See you soon.
Now, let's say you need to retrieve honey from the Bee Galactic Reserve. This bank is the most secretive bank on Mars, where bees store their valuable honey. The Bee Galactic Reserve stores a database of honey transactions in a private subnet of the VPC. To get there, you will need to send your request to the load balancer, which will distribute your request to one of the web servers. The web servers, after validating the request, will send it to an internal load balancer to distribute your request to the application servers. This application server will then talk to the database of honey transactions to get information about you and your honey, such as how much honey are you allowed to withdraw per day. Now, if you look at the process, you see that the load balancer and the web servers are in public subnet that allow requests from the internet. And the internal load balancer and application server will be in private subnet and only allow requests from the web server. Also, the database is placed in private subnets as well, and will only take requests from the application servers. This architecture is to make sure the internet doesn't have access to your database. Depending on the data classification, sometimes running our database in VPC's private subnet isn't sufficient. For example, if you handle data related to customer credit card information, then encrypting data address is essential to prevent data leaks. In this video, we talk about how you can encrypt data stored in AWS database services. For SQL lovers, you may already have heard or know about AWS Relational Database Service, or RDS. It is a managed service that makes it easier to set up, operate, and scale a relational database in the cloud. You can use SSL from your application to encrypt a connection to an RDS DB instance running Amazon Aurora, MySQL, MariaDB, SQL Server, Oracle, or Postgres. Each DB engine has its own process of implementing SSL. In case you are wondering, Amazon Aurora is a relational database service which features a distributed, fault-tolerant, self-healing storage system that can auto-scale up to 64 terabytes per database instance. The best part is, it is compatible with MySQL and Postgres database engines. You can encrypt your Amazon RDS DB instance and snapshot address by enabling the encryption option when you create Amazon RDS DB instance. RDS encrypted DB instance use the industry standards AES 256 encryption algorithm to encrypt your data on the server that hosts your DB instance. So, what will be encrypted, you ask? Data that is encrypted address include the underlying storage for a DB instance, its automated backups, the read replicas, and snapshots. To manage the keys used for encrypting and decrypting your RDS resource, you use AWS Key Management Service, or KMS in short. When you create an encrypted DB instance, you supply the KMS key identifier for your encryption key. If you don't have your own key, KMS will create one for you. What if you choose to use NoSQL database? Then it's time to talk about AWS managed NoSQL database service called DynamoDB. The good news is Amazon DynamoDB encrypts all user data stored in DynamoDB table by default. Server-side encryption address is enabled for all DynamoDB table data and cannot be disabled. You cannot encrypt only a subset of items in a table, though. When a table is encrypted, all the data includes its primary key, index, stream, global table, backups, will be encrypted. Encryption address integrate with AWS KMS for managing the encryption key that is used to encrypt your tables, and you can switch between keys. Check out our resource area for further details and documentation. That's it for now. Be seeing you.
So we've swarmed you with mentions of Amazon S3 throughout this course, but how does one secure S3? Well, you'd want to consider things like only allowing bucket access to authorized parties, and if you don't need public access, make sure it's disabled for a bucket, or maybe you want to add encryption to the equation. But wait, what is S3 again, and what's a bucket, and how do we prevent them from having holes? Simply put, Amazon S3 is cloud storage for the internet. And think of a bucket as a literal bucket where you can add, remove, or update objects. To upload your data, whether they be photos, videos, documents, you first create a bucket in one of the AWS regions, and then you can upload objects to it. But we're talking about securing those objects, and the first thing you can do is set up bucket policies. A bucket policy is a resource-based AWS identity and access management policy, which means that you designate access permissions for the bucket and the objects in it. So if you want a user to be able to read from a bucket, then you provision the relevant policy. Going even more fine-grained, you can dictate permissions for individual objects. But as a best practice for managing a whole bucket, we recommend enabling default encryption on the bucket itself. This means that all objects in that bucket will be encrypted, and that encryption can be centrally managed at the bucket level. Objects will be encrypted using server-side encryption with either Amazon S3 managed keys, that's SSE-S3, or AWS KMS or Key Management Service managed keys, SSE-KMS. Also, it should be noted that you do not incur extra charges for using default encryption for your S3 buckets, but you will be charged for the encryption keys themselves. For more information on the different encryption options and pricing for key storage, please check out our resources section. The last service we'll cover is called Amazon Macie, which is for those of you who like the managed option of securing your S3 bucket. Well, managed in the sense that Macie uses machine learning to automatically discover, classify, and protect sensitive data in AWS. That means Amazon Macie will automatically recognize your sensitive data, such as personally identifiable information or PII, even intellectual property, your IP, maybe even honeycombs. You'll then be provided with alerts on areas of interest, along with a dashboard giving you insights into how your data is being accessed, moved, and modified. Some of the things that Macie checks for are inadvertent exposure of data, insider threats, and targeted attacks. You can then alert on suspicious activities such as compromised user accounts and downloading of large amounts of sensitive content from unusual IP addresses, or maybe the download of a large quantity of source code by a user account that typically does not access this type of sensitive content. I mean, we don't want our secret honey formula stolen. For a list of Macie's features, please check out our resources section. Thanks for following along and learning how to secure your simple storage service, or S3. It's been fun, and I hope you enjoy our upcoming videos.
Welcome back, folks. This video is to discuss about encryption address for Amazon Elastic Block Storage, or EBS in short. EBS provides persistent block storage volume for use with Amazon EC2 instance in the AWS cloud. Amazon EBS is designed for application workload that benefit from improving performance, cost, and capacity. Typical use cases include big data analytics engine like Hadoop, relational and NoSQL database like Microsoft SQL Server or MongoDB. Another use case can be stream and log processing applications such as Kafka and Splunk. And another use case would be data warehousing application like Vertica and Teradata. When you need to encrypt data in an EBS volume, the solution is straightforward. You can configure your AWS account to enforce the encryption of new EBS volume and snapshots. That means new EBS volume will be automatically encrypted when you create them. EBS provides features to back up data in EBS volume to S3 by taking point-in-time snapshots. When you create encryption by default, these snapshots will be encrypted as well. EBS volume encryption doesn't require you to build, maintain, and secure your own key management infrastructure. Instead, it uses AWS Key Management Service, or KMS, when creating encrypted volumes and snapshots. For existing unencrypted EBS volume, you can create snapshots for the volumes and create new encrypted EBS volume from the snapshot using create volume or copy snapshot API action. When you create an encrypted EBS volume and attach it to a supported instance type, the following type data are encrypted. The first one is, of course, data address inside the volume. Then, all data moving between the volume and the instance will be encrypted. All the snapshots created from the volume will be encrypted as well. And all the volume created from those snapshots also encrypted. Encryption operations occur on the servers that host EC2 instance, ensuring the security of both data address and data in transit between an instance and its attached EBS storage. Amazon EBS Encryption is available only on certain instance types. You can attach both encrypted and unencrypted volumes to a supported instance type. Remember, you can check out the weekly resource section for further details. That's it for now. Space travelers, happy building! Hey, what's up? How are your bees feeling today? Let's say we have 2 AWS accounts, including one production account that has data stored in S3 and one testing account for testing purpose. Now, we are tasked to create cross-account access so that the IAM user on the testing account can access data stored in S3 in the production accounts. You can delegate access across AWS accounts using IAM roles. Let me show you how to do it. So in this demo, I created an S3 bucket called cross-account home in production AWS account. And if I click on the cross-account home bucket, I can see that there's a 2 file that I uploaded earlier, which is a picture of my puppy. So how do you grant access from a different AWS account to this S3 bucket? The very first thing you need to do is to go to permission and update the bucket policy. In this case, I updated the bucket policy earlier. You can see that for the IAM policy, I put in the principal as the ARN of the IAM user test account home from the testing account. So this IAM user is from totally different AWS account. I granted them the access to get object or put object ACL. So now let's look at the IAM user test account home to see how we can grant access to that account. I am in the IAM console of the testing account, and I click on the user test account home to see the policy associated with it. So to grant access for the S3 bucket in a different account, I need to give this IAM user permission to access that S3 bucket. And I create a policy called cross-account access S3. If I click on it, it will show me that this policy have allow effect that will allow me to get object, put object ACL, or list the bucket. And the resource that I am allowed to perform this action is the cross-account home S3 bucket. Alright, so now we have the IAM policy in place. Let's do a short demo to see how the IAM user can retrieve the file in the S3 bucket. So I have a terminal open as for now. Let's run an S3 CLI command to retrieve a picture stored on S3 bucket. So now we successfully download picture from my S3 bucket. Let's actually see if the picture is what I want to download. And yep, that is my pup. So thank you for watching. I'll see you again in the next video.
It's finally week 4, and you've really blasted through. Now it's time to talk about securing your application. A lot of this is going to come down to protecting your resources, protecting communication to and between those resources, and protecting your secrets. Everything has been going really well so far, so just keep buzzing through to the end. Good luck on completing your mission.
Hey folks! So glad you can make it to the last week of this class. As we went through multiple cloud security concepts, we haven't dived into how you can protect your compute resource. Let's do it right now. The first service that we want to talk about is Amazon EC2. You control the operating system and you configure and operate any identity management system that provides access to the EC2 instance. AWS will be responsible for protecting the hypervisor and the EC2 instance isolation. To secure EC2 instance, there are several best practices that we recommend. The first thing to do is to restrict access at the network and the OS layer. You can leverage security groups as the primary mechanism for controlling network access to EC2 network interface. You can also use network ACLs as a secondary control for denying a specific subnet of traffic or providing high-level subnet guardrails. On the instance itself, you should only install necessary packets for your operating system and applications. It is also recommended that the SSH key used to log into the EC2 instance need to be secure, and providing interactive access to EC2 instance should follow the least privilege model. Secondly, controlling the API access coming from EC2 instance is important. When your application runs on EC2 instance need to access other AWS services, you should use IAM roles to grant permission for the instance to make API calls. Using IAM roles eliminates the need to distribute and rotate long-term credentials on EC2 instance. Next, look at applying chain management and configuration management to control and monitor chains for EC2 instance configurations. We recommend to regularly scan and install missing patch for your instance. This is when AWS System Manager can help you to automate process around patching Windows and Linux EC2 instance. And last, apply security monitoring and auditing for EC2 resource and your account. This will include enabling AWS CloudWatch to capture API calls, which will enable AWS Config to audit and track chain made to your EC2 resource. Now, if you choose to run application in Docker containers, there are several container management and orchestration services available. Those services include Amazon Elastic Container Service, or ECS, Elastic Container Service for Kubernetes, also called EKS, and AWS Fargate. You can also run your containerized application on AWS Elastic Beanstalk as well. You'll maintain control over the container environment, the operation system, and the underlying EC2 instance when using Amazon ECS and EKS. For Fargate, you will not have access to the underlying compute resource. However, you will have control over the container environment. ECS, EKS, and Fargate lets you use IAM role to control requests from the application running on container to other AWS services. For example, you store a secret in an S3 bucket. To retrieve the secret, your containerized application run on ECS need permission to read the secret in S3. Thus, you create an IAM role and attach it to the container so that it can read the secret. Another compute service that we should talk about is AWS Lambda. AWS Lambda automatically runs your code without requiring you to provision or manage servers. You just write the code and upload it to Lambda. AWS will manage the underlying infrastructure and foundation services, the operation system, and the application platform for Lambda. You are responsible for the security of your code, the storage and accessibility of sensitive data, and IAM to the Lambda service and within your function. Each Lambda function runs in one or more dedicated execution environments that are used for the lifetime of the function, and then it will be destroyed. So you can use CloudWatch and CloudTrail to monitor and audit your Lambda functions, and you can also track configuration changes to the Lambda function using AWS Config. That's it for this video, folks. Hope your inner bees will be inspired to check out these AWS compute service. As always, don't forget to take a look at the resource section of this video to learn more about how to secure your compute resource. Ciao!
As part of securing your workloads, you need to protect your application endpoints. These endpoints are more than likely the ones that end users go through to interact with your application, and therefore it's critical to protect them. If we look at the traditional server-based infrastructure model with, say, an EC2 fleet, and as a reminder, EC2 is the computational building block at AWS, where you can choose specs such as memory, disk space, and OS, and then spin up an EC2 instance itself. You can start with one, and then you can scale out horizontally, even vertically, to have a whole fleet of servers. When you deploy fleets, you're going to spread the traffic across them like honey, in that you want sticky sessions. And a way to achieve this is with an AWS service called the Elastic Load Balancer. There are a few different types, with the two notable ones being the Application Load Balancer, or ALB, and Network Load Balancer, or NLB. The ALB operates on the individual request level, or layer 7, and the Network Load Balancer operates on the connection level, or layer 4. If you'd like to learn more about these load balancers, please make sure to check out the resources section. In our example, we're using the NLB, and you can see that we're load balancing traffic across our fleet using a round-robin algorithm, which rotates traffic in order between the instances. Our fleet hosts a website, and since we want to secure it by default, we require that the traffic is always transported over HTTPS. HTTPS in this case is a secure extension of Hypertext Transfer Protocol, or HTTP, and means that requests will be encrypted and decrypted. In order to achieve this on our EC2 instances, we route the encrypted traffic through the NLB and then terminate them on the instances themselves. Requests will then be decrypted on the instances, and the application can proceed further. This is a recommended practice for securing traffic to your EC2 instances, but it does incur a small performance impact for the actual decryption and encryption. So can we improve upon it? Of course we can. By using the NLB, we can terminate our HTTPS traffic on the load balancer itself, which will free your EC2 servers from the compute-intensive work of encrypting and decrypting all of your traffic. You also get some added benefits like simplified management, access logs, and improved compliance. For a full list of these benefits, check out our resources section. The next service we'll cover is called API Gateway, where API stands for Application Programming Interface. It's a fully managed service which allows you to create, publish, maintain, monitor, and secure APIs at any scale. By using API Gateway, you can expose certain application logic via REST or even WebSockets. In essence, you're only allowing access to needed parts of your application, and therefore you're not opening, say, your backend for the whole world. This notion of protecting your backend and other critical systems, such as your database, is a best practice for any architecture, and we highly recommend it when designing your next workload. Now say we're exposing a create beehive API call via our API gateway. How do we make sure only authorized users can use it? Well, you can add optional authorization processing, such as AWS Signature version 4 or SIG v4, even Lambda authorizers. SIG v4 works via AWS credentials, these being your access and secret keys, which authorize access by signing those requests to your service. When you create your API gateway service call structure, you essentially generate a custom SDK for your service. And this custom SDK will handle the signing for your requests. If you don't want to use permanent credentials, you can even use Amazon Cognito to retrieve temporary role-based ones so you can make calls to your API. The other option for securing your API gateway is via custom Lambda authorizers, which are actually AWS Lambda functions. And as a reminder, Lambda functions are the serverless compute offering on AWS and allow you to write your code as reusable functions in a language of your choice. We have several officially supported languages, such as Java, Ruby, Python, even Node.js, but you can include any language via custom runtimes. Now, these functions are executed in response to demand, so they can scale up and scale down as demand varies, with a maximum execution duration of 15 minutes. For a full explanation of AWS Lambda, please check out our resources section. Lambda authorizers determine access to APIs using a bearer token strategy, such as Open Authorization or OAuth, which is an open standard for token-based authentication and authorization. This means that if a Lambda authorizer is configured, API Gateway calls the Lambda function with the incoming authorization token, and, depending on the strategy you implemented, it will return IAM policies which are used to authorize the request. If the policy returned by the authorizer is valid, API Gateway will then cache the policy associated with the incoming token for up to 1 hour. And that's how you can secure your API Gateway. But that's enough of this for you busy bees. Thanks for watching, and hopefully you learn more about securing your AWS endpoints. I mean, after all, wasn't that the point of this video? Okay, my producers in the back are cringing, so I'll bid you adieu until next time.
I have a secret to tell you. You can store secret in Secret Manager. In the past, where your application would retrieve information from a database, you typically had to embed the credentials for accessing the database directly in the application. These database credentials can be defined as a type secret. They need to be carefully stored and handled. Other secret types can be password, third-party API key, and even arbitrary text. Handling of these secrets can be an important task in any infrastructure that requires secure handling and protection from unauthorized access. You also want to rotate your secret frequently to avoid things like stale credentials from being used against you. And keep in mind that your secret will need to be encrypted at rest and in transit. A best practice is never to lock the secret in system logs or application logs. Be careful about including debugging or locking statement in your code. You want to ensure that this login or information doesn't include any of the sensitive data that's stored in encrypted secret value. AWS Secret Managers is an AWS service that makes it easier for you to manage secrets. In short, AWS Secret Manager allows you to handle access to secrets without the need to store them locally on any instance or server or in any containers. It gives you the ability to have a centralized storage for the secret and provide direct access to only the necessary components. So, the way the Secret Manager works is: Step 1, an admin create or retrieve the secret. In this example, the secret are database credentials. Step 2, the admin then store the credential in secret managers and limit access to only the necessary user. Here, the user is a custom application running locally. Step 3, the application makes a call to secret manager using its credential that it has from the associate IAM role. And because the admin allowed for the application to have access, the application is then allowed to retrieve the credentials as shown with step 4 over here. Once the credentials are retrieved, they are stored in a non-persistent way, and then the credential can be used to access the database, as we see with step number 5. I hope that gives you some clarity, and in a later video, I'll demonstrate how AWS Secret Manager works. See you soon! Hello, Hong here. In this video, I'm going to do a demo to show how you can create and store a secret in AWS Secret Managers. Let's get started. From the AWS Management Console, you can search for Secret Manager to start using the AWS Secret Manager. On the right-hand side, you can store a new secret. Click on this button, and you have multiple options to create the secret, right? You can choose to create a credential or secret for RDS, for Redshift, for other type database. You can also choose to store an API key. In this demo, we're going to start with creating credential for RDS database. So the credential in this case will be the username and the password for the database admin to log into the RDS instance. In this case, I'm gonna create a username admin, and the password, I can just pick a simple password, right? Test account. But you want to make sure that the password for production database need to be following the best practice, right? That's including special character with the appropriate length. So in this case, I can choose to use default encryption key, which is the KMS key that created in your AWS account. I can choose to use my own KMS key that I created in KMS. I'm just going to stick with the default encryption key. And this is where the magic happens. You can see that Secret Manager automatically pull out the database instance name that you want to associate the username and password with. And I have one test, Aurora DB, which is an Aurora instance available in the same region that I'm storing this secret, with a Oregon region. So let's click on next. And in this case, it asks you, what is the secret name? In this case, I'm going to name it DB admin. And for the description, I will say username and password for our beloved database admin. Done. Now for tags. Tagging is one of the best practices we recommend for you to control your AWS resource. So in this case, I'm going to tag department, and the value would be IT because we want to control which resource is created by and maintained by which department. Click on next. And this is the fun part. You can choose to automatic rotate your secret and let Secret Manager do that for you. In this case, I'm going to choose enable automatic rotation. You can choose 90 days rotation, 60 days. I'm going to stick with 90-day rotation. And you can use a Lambda function to perform the rotation for you. I don't have a Lambda function right now, so I'm going to let Secret Manager create a new Lambda function for me. And I'm going to name it database admin secret rotation. Awesome. And this lambda function will be used to rotate this specific secret. Click on next. And now it's just the review, right? We choose to store credential on secret manager for RDS database. We choose the default encryption key. We choose to name it as a database admin. And now secret manager gives you some sample code that you can integrate with your application. So if you look at the Python code, right, it's just like, hey, there's a function called getSecret, so that you talk to the endpoint of secret manager to pull out a secret for you in the application. And finally, we click on store. And bam, here you go. You have a new secret called dbadmin, stored and rotated by AWS Secret Manager. So that's it for now, folks. Thanks for watching.
Wow, can you believe it's been 4 weeks since we started our mission to build a bee colony on Mars? I'm so happy that you stuck with us on this buzzing journey. And as a final piece to the puzzle, let's talk about the well-architected tool. Before we dive into the tool, we have to mention the actual well-architected framework. It is designed to help architects, developers, and users of AWS to build secure, high-performing, resilient, and efficient infrastructure for their applications. It's composed of 5 pillars to ensure a consistent approach to reviewing of architectures and designing for scaling over time. And since this is part of my day job, I'll tell you the pillars right now. It's cost optimization, operational excellence, reliability, performance efficiency, and security. You're probably wondering why I name them out of order. Well, I like to use this handy acronym to remember them. CORPS, or CORPS. Now you can be an architect like me too. In the past, you'd need to evaluate these against your AWS infrastructure with the help of a solutions architect. But we listened to customer feedback and decided to release it as a self-service tool. You can now access it via the AWS console, create a workload, and run it against your AWS account to generate a report showing areas that should be addressed. It's similar to the traffic light system with AWS Inspector, with green being, "A-OK, Captain, keep up the good work." Orange being, "You should probably look into this because there's room for improvement." And red being, "Okay, you gotta address this, else you're gonna be sent to the principal's office." And by principal, we mean the principal SA. You see what I did there? No, but seriously, these are the areas where the tool has detected potential issues and provides you with a plan on how to design using established best practices. If we take a look at the tool itself, you'll see something similar to the following screenshot. As I mentioned, we name our workload, and that appears in section 1. Section 2 shows you the pillars and drop-downs into the questions for each. Section 3 shows you the actual questions themselves. 4 is pillar and question stem. 5 is a bit of background and recommendation. 6 is the answer you provide with the toggle to dictate whether the question is applicable or not. This is important as it affects your overall score. And oh, I can't forget about section 7, where you'll be presented with short videos explaining how to answer a particular question. And in the performance efficiency pillar, you'll notice that this handsome gentleman is your guide. Man, that dude is cool. I mean, I wish I could be more like him. Anyway, thanks for going along with us in the secure journey to the Red Planet, and good luck with securing your workloads in the future. Oh, and since we're so nice, we'll leave you with one final quiz.
Congratulations on making it to the end of the course. We are so glad that you joined us for this mission.
We hope this was beneficial to you and that you come away from this class with some helpful information. As we stated multiple times throughout the class, make sure you read through the notes and AWS documentation.
Be sure to try implementing the service and best practice that we discussed to make sure you have a solid understanding of the concept that we covered.
We also want to remind you to look at the website shown on screen and in the notes for more information on AWS training opportunities.
We hope you have a good time.
And hopefully we'll see you in another class.
Buzz, buzz.
That's B-Speak for see you later. Cheers.